Next curve.
Welcome, everyone, to Next Curve's reThink podcast. In this episode, we, as we always do, break down the latest tech and industry events and happenings into the insights that matter from the world of semiconductors and Karl's most favorite topic, AI, second only to quantum, I would say. Right, Karl?
Yeah, quantum.
Right?
We got to talk about quantum.
Yeah.
I talk about quantum.
Really? Okay. All right.
Oh, yeah. No, there's a huge announcement about quantum this month.
Ooh, okay. Well, hey, everyone, this is going to be really, really exciting. And we're going to get some fantastic insights from these two. So, yes, I am Leonard Lee, Executive Analyst at Next Curve, and I'm joined by the very relaxed and tropical Karl Freund of Cambrian AI research and soon to be quantum research. And we also have, I'm at loss of words and adjectives for you, Jim.
Good.
I was going to look up something in the thesaurus, but Jim McGregor of the famed Curious Research. And in this Silicon Futures episode, we'll be talking about the hot headlines of July that mattered, and that is going to undoubtedly include topics such as, quantum, AMD Advancing AI 2026. We must talk about that. Maybe we'll touch on Samsung's Galaxy Unfold with Galaxy AI and what's going on there. From a silicon perspective as well, and we've
got Meta's Iris, that's going into production.
Okay. So we'll touch on that. And Karl, we want to talk about the gigawatt. Is it a good metric for quote unquote AI capacity? And what the hell do we mean by AI capacity? OpenAI. Hey, we have to talk about this. OpenAI and Anthropic's rogue agent crisis, or is it really a crisis? Right. And this weird thing that's happening this month, this turmoil around open models, right? There's a lot of stuff happening there. We should talk about that debate that's going on. And then the state and impact of memory. We have to talk about that, give our audience an update on impact and influence on the supply chains across the electronics.
And definitely our forecast, is AI coming to a head, or is it continuing to barrel forward?
But yeah, and then token, and in that regard, let's talk about token maxing.
Token shock.
Yeah. Where is it going, and what are the implications? And probably more. But before we get started, please remember to like, share, react, and comment on this episode. And also subscribe here on YouTube and on Buzzsprout to listen to us on your favorite podcast platform. Opinions and statements by these two gentlemen right over there are their own and don't reflect mine or those of Next Curve. We're here to provide an open forum for discussion and debate on all things, AI, quantum, and silicon for informational purposes only. So let's get started, gentlemen. Let's talk about AMD Advancing AI. What do you guys think? What are the things
that's definitely the biggest news of the month.
Yeah.
There's lots of news this month. That was the big one. And they announced a lot of stuff that we already knew was happening. MI 450, 455, Helios rack. They announced some customers. We all knew that was happening. What they announced that nobody knew was going to happen, but some of us suspected might, was the relationship with Cerebras. So they're doing the same bifurcation of inference processing that NVIDIA did with ROC. They're doing the same thing with Cerebras. And I won't make any judgments as to whether Cerebras or ROC is a better partner. I will say that Cerebras is still independent. And AMD did not acquire their assets nor their leadership. And Cerebras is working closely with Amazon AWS to add a disaggregated inference platform for AWS. You can check my Forest blog. I wrote a blog about disaggregation, inference disaggregation, what that means to the market. and the various players of the market. So check that out on Forbes.
Now you say that AMD didn't acquire the management, but in the past it had.
It had.
Actually, Andrew Feldman
that very man
was acquired by AMD.
It was acquired
once upon
by
a time.
AMD.
So it's kind of funny, but that was a kind of an interesting choice because of all the inference processing solutions out there. Not saying that Cerebras has a massive processing capability, but it's a wafer scale solution. It's not. I mean, it's a large solution. It's an expensive solution. The question is it going to be a competitive solution when paired with AMD? And is it going to be, in the same? I mean, even the racks that they use are different sizes than the Helios rack. The Helios is a double wide OCP standard. Yeah. So it's going to be interesting. They didn't provide too much information about that, how that's going to work, and the pricing and everything else. And Cerebras has already gone down a different road to be a service provider and opening up its own data centers, with its financial backing from the Middle East. So I'm not quite sure how that's going to work yet, and I'm not quite sure if that's the right solution. But obviously, AMD definitely, has to have a complete solution, which includes training and inference.
Yeah, and I think it falls in line with what Lisa continues to tell everyone, which is AMD is taking more of an open approach. So the way that they're engaging with Cerebras, the way I characterize it, is loosely coupled. So it's not this acqui-hire that NVIDIA did with Grok. And so I think that gives, number one, both companies agency, but that partnership, I think at a technical level, also gives them a lot of flexibility because, the whole inference market and the way that these models are evolving and what optimal looks across and now what's becoming an increasingly heterogeneous landscape of compute, that flexibility might be really important going forward. So it's not about putting all eggs in one basket. It's really trying to figure out, okay, as these models evolve and these model architectures and agentic frameworks continue to evolve, what kind of system do you need to put together, and who are the best partners for certain types of, let's say, applications? So when we look at applications, AI applications now, we have to look at, well, okay, what are the agentic compute requirements, and then what are the things that are model specific and the harness and all this other stuff. These systems are not just about the model anymore, and we're now departing from this regime that we're all used to, or many are still kind of in, is this mindset that AI compute is all about training and what's optimal for training. And that's obviously changing as we start to see the diversity of inference and then now agentic start to influence what optimal means for AI compute. I don't know if you guys are seeing that.
I'm glad that you also brought up that AMD is taking that open approach because the Cerebras announcement may not be the only announcement. Yeah. There still might be other partnerships or other acquisitions to address different types of agentic and or AI workloads, inference workloads. So it'll be interesting to see as that develops. Obviously, it's still early days for AMD in that segment.
And we don't know what the performance will be. We have no idea. No. It's interesting talking with Andrew. I said, how did this come about? He's like, first of all, the conversation was easy because we just connect over PCIe and Ethernet. And I'm like, well, that's good news, but it's also bad news because Grok and, not Grok now, but the LPUs and Rubin are connecting with much more co-designed low-level chip-to-chip interfaces, so they can get much higher performance theoretically. So the good news is Cerebras can connect to anybody. Bad news is they can't. There's not a lot of advantage. Now, Andrew would say, "Well, I don't need to have a high-speed link. We're just sharing. We're just sharing the cache, right? The KV cache. So." We'll have to find out. These guys know a lot more about it than we do.
Mm-hmm. Yeah. And that could very well be the case depending on the application, right? And so I'm saying the application, then you have all these different workloads, right? It's not just a singular workload anymore. It's a series or a chain of workloads. So, the latency requirements, the bandwidth requirements could be very, very different depending on the application, right? And one of the things that really stood out for me from AMD Advanced AI was how, AMD is really taking the charge on the CPU for AI, right? They have different SKUs now, different configurations for different kinds of workloads that they anticipate or they do see being required to support agentic AI, right? And again, going back to this notion of you have the application, you have like the agentic and AI frameworks underneath, the diversity of CPUs that are going to be required to make these applications happen, right? And so with Epic, she described it more as a portfolio now rather than a particular generation of chip. So I don't know what your reaction to that analysis was.
We've seen that for the past couple of generations where they've come up with different SKUs for different applications and different things. So we kind of expect that. But I mean, we have to remember also that they're not just focused on the data center. They did talk about Halo, which is their small form factor workstation. They did talk about Edge AI, especially with their Xilinx solutions. And I think people forget that Xilinx has actually been doing robotics and some of these applications for decades. So, matter of fact, they've been a standard platform for FIRST Robotics for quite a long time. So, I mean, these are not new markets for AMD. AMD is one of those solutions, one of the few companies that can go from the edge to the cloud and from, physical AI to agentic AI.
Mm-hmm. Mm-hmm. Karl, you're going.
Yeah, no, I agree. I think it's an easy card to play. It's in your hand. You've got a whole portfolio, and NVIDIA doesn't. So play that card. How meaningful is it for the data center? I don't think it is.
Really? Okay.
No. You don't. Heterogeneity is good in the data center to a point, but if you end up with a suit made of 1,000 different SKUs, that's not going to be manageable. Mm-hmm. And so we'll have to see.
Sure. Yeah.
I mean, do you really think hyperscalers are going to want 5 different Epic CPUs?
Actually, I would say yes, but they won't be using them all for AI. So, I mean, they'll still want a CPU for enterprise workloads. They'll still want a CPU for communications. They'll still want a CPU for other applications.
But for inference processing?
Yeah, I don't necessarily think that it's going to. Well, a CPU can do inference processing, but let's face it, you're still not going to get the performance or the return that you're going to get with a dedicated accelerator.
Yeah.
Well, but let's take a step back. We're not saying that the CPU is replacing accelerators or GPUs or what have you. It's doing especially with the Agentic, with the Agentic frameworks and just any AI application. And you saw this. So when Jim, were you at ARM Everywhere?
Yes.
Yeah, you were there, right? And so if you went to one of the demo booths, they had this really cool chart that showed you an agentic flow and where compute workloads were placed through that entire agentic flow. And this is something that AMD actually highlighted as well. Actually, most of the workloads, and whether it's supporting or core, run on CPU. And it's not that they're running AI. When you look at the overall AI application,
it's the orchestrator.
The GPU actually doesn't do that much in the context of the overall flow of tasks and operations. Which is, it seems counterintuitive, but that's actually what we saw with RAG when semantic search was a big deal. hyperscalers are noticing, especially ones that were looking at leveraging it for recommendation engines, but also like search, that a lot of the workloads for the retrievers would be driven off of the CPU. So this is something that is not well known, but these guys are now making it well known. And this is why we've seen the CPU business of these companies in the background kind of ramp up as we're looking at these AI numbers, growth numbers. Actually, there's been this shadow growth in CPUs because of this reality. And obviously, there is that trend of refresh, right? There's typical IT refresh of a traditional compute, but now we're hearing more and more how a lot of the traditional non-accelerated computing is becoming more important in even these agentic applications, whether it's tools, what have you.
It'll be interesting to look
That's
out.
the point. I think that's important to clarify to the audience.
And I think it'll be interesting when we start adding these other accelerators to the mix. So now I'm going to have lots of CPUs. I'm going to have GPUs, and I'm going to have LPUs or whatever you call them.
And NPUs, right? and
NPUs,
FPGAs, and DPUs,
it's quite heterogeneous. The nice thing is that you can mix the ratios depending on your needs, right?
Absolutely.
So some places will have 4 racks of LPUs, 1 rack of Rubens, and a rack, and a rack of Vera, and others won't. So
I think the greatest challenge is definitely going to be architecting these as a single system. Not just within a rack, but the clusters that you have to put together. So I still think that's where NVIDIA has a significant lead in doing more of the entire platform, and the fact that they're architecting everything to work together, and they're working with companies like Vertiv and stuff like that to make sure that the cooling, the power, and everything else just all works.
And and that one of the comments that I made in my key takeaways from this event was that, AMD is about 18 months behind on ecosystem. And, I put this caveat. That might not necessarily be a bad thing, but, we noted this long time ago, how aggressive NVIDIA is like moving up the stack, right? And so you're absolutely right. I agree with you, Jim. Your name is Jim, right?
Yes.
Okay.
Well, and the other thing that, obviously NVIDIA is very aggressive on the software side, especially the model side. And they're They're open sourcing more and more content, especially from that CUDA library, than we've ever seen before, for chip design, for biosciences, for you name it. But I would say at least both companies, especially AMD and NVIDIA, are continuing to invest in the ecosystem and invest in the rest of the industry as well.
And NVIDIA's investments are part of their circular financial arrangements with their customers, right?
Well, so are AMD's.
But to a much lesser extent. They have a lot less money to throw around. And so Jensen's sitting here thinking, okay, I can give this back as a dividend, maybe a one-time dividend of $50 or something. Or you can say, or I can invest in these 20 companies that are eventually going to buy a lot of GPUs and create new markets for more GPUs. And he's taking the latter path. Aggressively.
AMD's got some huge announcements with Anthropic and OpenAI.
That's true. They did.
One of them even involves 10% of AMD stock.
So, and then,
I think NVIDIA's investment has a much longer tail. Right. They invested in Chip Agent. Right? We could talk about Chip Agent, and it's like another time. But the use of AI to develop chips is critical to NVIDIA.
Well, and let me throw this out there for you, because to both of you, because one of the things that I thought was super interesting that AMD announced was ROCm.ai. And so that's like literally AI, using AI to quote unquote vibe code kernels and support kernel optimization for these low level, and I don't mean like low level meaning menial, but the AI engineers who work really close to the metal. Well,
Yeah,
what do you guys think about
the data
that?
scientists and stuff? Yeah,
Yeah,
they're trying to up level it. Yeah,
yeah,
no, I think that's a very important task. I mean, the more you automate, and the more, I mean, we've seen this even, I think, with Agentic AI, just with the open claw movement, people being able to generate their own types of agents and everything else, that is, and the whole shift towards open weight models, I think that we're seeing that with Kimi, obviously, and other solutions. It is moving that way so quickly that, AI is even, it's funny because I actually talked to a couple developers recently, and they were saying, listen, we were doing everything kind of, as close to the chest as possible. But every, couple of months, NVIDIA and other companies, especially NVIDIA, had come out with some new feature, and we didn't have to do that anymore.
yeah.
So now it's to the point where, we're identifying what we need to do, and then we're just waiting, especially for companies like NVIDIA, to just come out with it so we can just jump on it, use it, and we don't have to worry about, wasting all the engineering resources and the time and everything else. And AI is proven to be there. And
Yeah.
I don't know if you want to get into that now, but just seeing what some of the new models at OpenAI were able to do to break out of a system and break into somebody else's system.
Well, let's hold that for later. Let's talk about that later once we finish. Yeah, that, which is like the craziness of this month. I mean, we thought that June was crazy. July ends up being even more, wacky is the word that comes to mind. But so I'm looking at it more the standpoint of how there's this talk track or this notion that AMD is so behind on the quote unquote software side of stuff, especially due to the CUDA moat. Jim, you've already talked about how over the years, NVIDIA has created this massive library of stuff. They have a whole, literally a stack that extends all the way out to enterprise applications. Mm-hmm. And the question now is, given all this vibe coding stuff and the fact that, let's face it, AI is pretty damn good at coding, right? And if you can use it to do all the assembly language level stuff for kernel programming and optimization, what's the possibility that AMD can force multiply their developer communities, or even internally their own product teams, software product teams, to very quickly scale out and maybe not catch up in short term with NVIDIA, but make traction in some critical areas that would make AMD's AI compute stack much more competitive, and that's what I thought was really interesting with ROCm.ai, and that's something that I'm going to be, continuing to monitor, and we'll probably talk about
It's interesting. About a year ago, Dylan Patel, SemiAnalysis, just took out a sledgehammer and just crushed AMD because of the quality or lack of quality and functionality within ROCm. They said it's a piece of junk.
Yeah.
But they didn't stop there. They actually sat down and worked with the AMD engineers to fix it and improve it, and they've come a long way. But now Dylan is saying, yeah, but you don't have any hardware to test it on. Your engineers keep telling me there's not enough internal development platforms of scale to be able to test this stuff out at scale. And that's because they're shipping anything they can make in this incredible environment. So it'll be interesting. I suspect they'll solve that problem. It's not a hard problem to solve. It's just a matter of making some tough decisions.
Yeah, exactly.
But to your point, Leonard, I mean, we're still in the infancy of AI, and it's anybody's game. I mean, from frontier models to software, it is anybody's game.
I agree.
I don't know. Okay.
And I wouldn't count AMD out by any means.
No, definitely not. Definitely not.
I mean, I don't know if we're at the beginning of AI. There's just, I don't know how valid that is or constructive. The thing is that we are where we are, and the ecosystem needs to figure out how to monetize this stuff. I mean, there's a huge gap, right? It's becoming more and more obvious all the time.
Well, I think it's a gap for companies like Meta, but when you look at Microsoft and Google and everyone else, they seem to be monetizing it pretty well.
Pretty
Well,
well.
it depends. And but that's where we have to really dive deeper into the numbers, and it's still pretty obscure, right? They don't break things out in the way that would support an analysis on where is the AI monetization.
Matter of fact, if anything else,
problem.
I would say the biggest problem right now is token shock. And just the fact that
we go.
You start driving engineers, and not just engineers, developers, anybody within the organization to start using AI, and even giving them budgets that they have to meet or levels they should be using. And all of a sudden, you start finding how much this costs to generate all these tokens and all this data center server time. It's getting very, very expensive. So it's pushing a lot of developers, a lot of organizations, to this open weight models, and B, to on-prem solutions like the small form factor workstations, the disk side workstations, or even on-prem servers, because it's getting so expensive to use some of these services now.
So, Jim, where does that leave the foundation model, the proprietary models? What's your view on that?
Well, first off, there are some applications and some organizations they're going to they're almost required to use them. And when we start thinking about finance and healthcare and government and stuff like this, you have to have a certain level of assurance that it's going to abide by the guardrails. It's you're going to see certain upgrades. It's going to be fully tested and vetted before you get it. So I don't think that there's a limit to the growth for frontier models. But and this is kind of a generational thing too. I mean, when you see startups, you see a lot more of the startups and newer developers, immediately going to those open weight models and start experimenting with them and start using them very, very quickly. So, when you have those younger engineers and those younger companies, all kind of pushing towards that open source solution, it's going to bifurcate the market. I still think you're going to see growth of the frontier, but I would say by the end of the decade, that open source solution, if it's not at least 50% of the market or more, I'd be surprised.
Yeah. I mean, I think the biggest challenge for the foundation guys is diffusion. And, we don't hear Google a lot in this. So let's talk about this whole open model debate that's going on. We had Jensen lead a cadre of tech companies to sign an open letter to the government advocating for open weight models, right?
Yes.
And full disclosure for NVIDIA, they have their own, which is NeMo, their whole Nemotron family of open models. And then subsequently, after the OpenAI rogue agent incident, then you had NVIDIA once again announced that they're working with, I think it's around 37 companies to form what they call the Open Secure AI Alliance, which I think really should be called Secure AI Alliance, because secure AI is agnostic of whether or not it's open or closed. But the whole idea is to be able to leverage, I think, open models and develop tools to secure AI going forward. Make it trustworthy, I think, is one of the terms that they use, and then safe. So it was like a bunch of mishmash of feel-good terms, but I think the general gist of what everyone's trying to react to is the security threat that now that mythos moment has shined a light on. And so my view is that everyone's reacting to that and trying to figure out how to capitalize on that revelation. But these. So, anyways, let's talk about the open models. And And so here, this is my take. Diffusion is going to be the biggest challenge. Google, less so because they have the Gemma stuff. Okay, they're on endpoint. They're already, nicely diffusing out of the data center. They have a footprint. The likes of OpenAI, Anthropic, I think both of you will agree, not so much. And so they're on the back foot there. And the challenge with the open models is that you're going to probably see these large capable models then be distilled and compacted down into much smaller, capable application-specific models. There might be some fine-tuning that happens, yada, yada, guardrails applied, boom, this thing is capable for that use case. And so you'll see diffusion happen outside of these large data centers because of economics that you mentioned, Jim. So that's sort of the dynamic I think is going to play out here with the open models and why it actually is a pretty big threat for frontier labs, especially the US ones. So, hey, you guys don't have to agree with anything I say. Let's make this exciting, backyard wrestling style.
I don't have that slap feature yet. We still need the slap feature on this.
Just go like that. And I'll put the sound effect in. Come on, Jim. Come on, Karl. What do you guys think? No? Look at this guy. Come on.
I think you're likely right. I'm not sure what the implications will be to the overall industry, and I focus mostly on the hardware side.
Yeah.
So I think the hardware layer, it doesn't really have to worry about it. I think they got the businesses running stuff and securing the monsters we've created. That's a totally different ball of wax.
Yeah,
I think the agents take care of a lot of that diffusion, so I don't see that as being a major hurdle at this point in time. I think that, quite honestly, I expect it to be part of the orchestration. So, and let's face it, I don't know of a single organization that's using a single model, because they're using whatever model or whatever tools make sense for that particular reason, in that particular application. And now we're introducing we're introducing the agents to do a lot of the human tasks that we normally do. So the agent is making that decision, and the agent can do it much quicker, much faster, and can handle that diffusion, from different levels of the hierarchy, the hardware and software hierarchy. So I don't see that as, I really, I understand your concern about it, but I really think that is something that is organically being addressed very quickly.
Yeah, I'm not concerned about it. It is what it is for me. I'm just, I'm sharing a view, and I think, I think security is a big challenge. I mean, we can't ignore the fact that really the core issue here, and the thing that is really creating is shaping the talking points, is the security concern. Whether it's concern that it's a Chinese model, whatever, however that affects the perception of security and trust, and now. What we're seeing with the Mythos moment is now, like, a lot of environments, including the hyperscale environments, are massive, potential environments for zero-day vulnerabilities.
Well, and massive ones that we didn't even know about.
Right.
Across the platform. The fact that
across everything.
Agents that can find zero-day vulnerabilities across platforms, across software solutions, across the, quite honestly, I think that AI will actually enhance security even more than the threat. Because think about it, no, I think it will. I think it will. I mean, just the ability of AI to react to threats and react to people, acting, agents or people or whoever acting in ways they're not supposed to act. They can do it much quicker, much faster, and they can adapt to it. I think the issue is, and what we've seen is the fact that AI wasn't in that role of handling the security threats. If it was, I think that that's an evolution that our industry is going through, but I think as AI takes on that responsibility, I mean, even think about it like today. One of the big issues is the fact that you can pretty much see any brand new movie just by pirating it. Somebody's pirating it somewhere around the world. These sites go up, and it takes 6 months to take them down. When AI gets involved, those things will be down in minutes or seconds. So no, I think that, once AI gets, matter of fact, I'm almost worried about AI going too far with security and not letting us do some of the stuff that we may want to do. So I think that there's a delicate balance there.
Yeah. And that's kind of like what happened with the, in the OpenAI situation where GitHub had to resort to a Chinese open weight model, because, Mythos was locked down. Right.
Yeah.
It had a guardrail that prevented them for, doing the analysis that they needed, the forensic analysis that needed done. So, I mean, I'm more on the side of, it's not the side of, but it's, I subscribe to the challenge that the cybersecurity industry has always had, which is it's an asymmetrical fight. And in my research on the cybersecurity side and safe AI, the threat actors have the advantage, and that should bother everyone. And the AI,
I think they have the advantage now, but I think that's going to change. Once again, when you have AI agents that are the ones that are actually doing the threats, that are actually the main threat that you have to deal with today, that's one thing. Especially when you don't have that same level of AI on the security side. But that's going to change very, very rapidly.
Yeah, and I'm keeping track of that.
I mean, it's almost like a BattleBots competition between AIs, and that's what it's going to be like.
Yeah, it's just one side has bigger clubs and a bigger head. Anyway,
sometimes it's a lot easier to be defensive than offensive.
Okay, so we'll leave it at that. That's a good debate to continue to have, and I'm sure it'll keep coming back. The security issue is huge.
Oh, it will, but just to raise it to a level where it's going to stop innovation or slow innovation would be foolish.
Yeah, no, I totally agree with you. No, it's an urgent matter. But Karl, let's talk about really quickly this whole gigawatt thingy. I keep hearing it used as, hey, we have XYZ gigawatts of AI capacity. Okay, so I'm being I'm mincing words.
I really think it's simpler than what is concerning you. You only have so many gigawatts that can come into a building, and you will do a certain amount of AI on that, depending on how you architect it and which chips you acquire and how you build it and manage it. But you got to have something besides TOPS. Remember TOPS?
Yeah.
Right. The terribly overused performance statistic. It's meaningless. It's meaningless. So gigawatts is at least how much power you're going to consume. What you do with it is going to determine how much AI it produces.
Think of it this way: these really are factories. They're taking data and they're taking power and they're creating information. They're creating tokens. So what's the biggest limiter? It's not the data, it's the power. So, I mean, that's why we're using gigawatts, is because that is the biggest limiting factor that we have.
Yeah, but is that really a metric for AI? Because the problem is you guys are using that terminology and that mind frame down closer to the data center and infrastructure level. That's now being digested above the stack as entirely something else.
Well,
They look at gigawatts in terms of a measure of, AI capacity, whatever the hell we mean by AI.
Well, first off,
because remember, everyone's trying to figure out how to calculate and attribute all the spend to economic benefit. Right.
Well, and at the same time, people are trying to future-proof their solutions. It's almost impossible to plan for because you have models are increasing by 10x each generation. So you can do 10x more, or you can do the same or better with a model that's a tenth of the size with each generation. At the same time, we have hardware performance increasing by 30x or more with each generation. So I mean, those are phenomenal numbers just to show how much more efficient we're getting at creating tokens. However, and it's making it more cost effective. However, how does that plan into what you actually can do in the data center? You still only have so much power coming in, but the power, to your point, the power is not going to determine what you can do or what the token output is. The token output is still going to be a combination of those factors of what hardware you have, what models you're running, and what and what generation you're on.
Yeah, I think the disagreement we may have here, Leonard, is that I don't think you could apply gigawatts power as a metric of how much AI you can produce.
No.
It's simply the input. It's just the input. It's not the output.
It's the limiting factor.
Metric. Yeah.
Yeah. It's the limiter. It's the upper limit of, okay, you've got this much power. What can you do with it? That's it. It's one factor in the equation. Matter of fact, if you really want to look at the performance of a token, there's like 6 different factors that factor into that. This is only one of them.
Yeah. Actually, I don't think that there's that much of a disagreement. It's more of, do people know what you just described?
I actually have a slide on that.
No, because think about it. The different audiences that are consuming this information, making decisions on information related to this metric, do they understand everything that you said? Because right now
it is difficult. One of the biggest questions we get is, how do I future-proof? How do I build a system that I'm going to be able to use for generations, and how do I plan for that? And it's almost impossible. It's almost impossible. It's like, okay, each generation, you have to understand that the software is changing, the hardware is changing. The only factor you have is what you have in terms of physical resources, and that's it. Because the rest of the AI equation is going to change constantly.
So to our audience, earmark this section of the podcast. This is really important because I get into so many conversations with people who are completely confused, and believe it or not, the gigawatt thingy just confuses them even more. And so this is good. I'm not making an argument here at this point because I thought I was. You guys are actually doing a clarification based on what you're describing and reacting, probably with the intent of beating me up and slapping me. You have done the world a favor.
No, and that is a challenge when you look and say, okay, well, Meta's building a brand new gigawatt factory. What does that really mean? That doesn't translate into their capacity for tokens, and it doesn't translate into ROI until you actually get that up and running.
Yeah, definitely. Yeah. So no, this is good stuff. And then so, hey, we had a little...
We have to talk about quantum because there was a major quantum announcement.
Bring it on.
That was that IBM, who is one of the leaders in quantum computing, and especially in supercomputing qubits, actually acquired HRL Laboratories, which is jointly owned by GM and Boeing, which is developing a number of quantum technologies, particularly silicon spin bits. So now, and this is a technology that Intel and others have invested in over the past decade or so. So now IBM now has two quantum qubit technologies that they're working on, as well as additional stuff like quantum sensing, quantum materials expertise, and cryogenic electronics and packaging technologies that HRL Labs brings into IBM. So this is a huge acquisition for IBM, and quite honestly, I think lifts up the potential for the quantum spin bits even more. Would you agree, Karl?
I definitely agree. I've been wondering what IBM's going to do, because superconducting is really amazing. It's really fast, but it's really expensive. And you've got things like, neutral atoms and trapped ions and quantum spin bits that are much more cost effective at producing quantum calculations. So it'll be interesting to see how this informs their future roadmap. They've got a solid roadmap. They're spending billions of dollars on it, and they will get to a superconducting quantum computer by the end of this decade that is both scalable and fault tolerant. And so that's the roadmap. Now, how this acquisition changes that roadmap, they're not saying yet, if it does or whatever. Personally, I'm more intrigued of late with neutral atoms. It's not as fast, but it's much more quiet. It's not as susceptible to the environmental changes to the state of a qubit. And
durable, you mean? Is it?
It's more durable. It's got longer states in which the superposition can be maintained. Not in milliseconds, but in multiple seconds, you can maintain the superposition of the qubit, and that determines how long that qubit is actively computing. So I don't know. The good news is that all of these qubit methods will produce quantum computing results by the end of this decade that will change everything. What's not clear is whether we've done a good enough job. Well, I guess it is clear. We haven't done a good enough job in protecting the world's data from the attack of quantum busting of all those crypto keys. So, there's this, save it now. Eventually, I'll have enough computing power to break it. And when that happens, I've seen estimates as high as 3% of the world's GDP could be wiped out.
Companies have to be ready. They have to be post-quantum safe today.
We've got the post-quantum algorithms, and IBM's worked with NIST to standardize on these quantum-proof algorithms. But I don't think everybody's too busy chasing AI, and they're spending all this money on chasing AI instead of protecting their data. And the world's going to be in for a nasty shock. That is kind of beyond the scope of anything we've ever seen before. If all of this saved data, proprietary encrypted data, suddenly becomes open for harvesting.
Mm-hmm.
Yeah, interesting. Yeah, and so Jim, Karl, do you see this acquisition as being sort of complementary or more of a diversification approach? And by the way, to the audience, we did these two gentlemen presented on the various quantum approaches. We have a separate podcast episode for that, so definitely check that out. It's a great education, by the way. And anyways, but maybe you could help us understand, is this complementary diversification on IBM's part?
Well, it's still using standard silicon technology. So you're not using lasers or optics or anything like that. So it is complementary in that standpoint, the fact that it's something that IBM knows very well, and that is silicon technology. So I think it is. And I think that, like Karl said, everyone's realizing that there's not going to be one way to skin the cat. You have to look at different quantum technologies, and some are going to scale better than others. Some are going to be more cost effective than others. But I think having multiple, matter of fact, Jensen Huang said this when he was talking at their quantum day, that, I would recommend that companies go out and invest in at least 3 quantum technologies, because, there probably multiple ones are going to coexist simultaneously.
Okay.
And I would agree with that. And I think that the more and what we've seen, especially with IBM, is IBM invests not just in the silicon, but they invest in the system and the environment and the ecosystem.
Yeah.
So I think that's bringing a lot of that together, because some of these people that have been investing in some of these technologies, even like the silicon spin bits, some of them have, even though they've been investing for a decade, they haven't put as much into it as others have, especially IBM. So I think this brings a lot of investment to it.
Okay. Interesting. So what I want to ask both of you this question really quickly. This is a quick one. Intel finally, at least publicly, committing to 14A. What do you guys think? No big deal?
Well, no. Talk to them. Well, first off, I've always said that they're committed to 14A, because their products are planning on running on 14A, and it's a step function for them from 18A, using the same equipment and everything else. So I've always said that they're committed, even if they didn't say it publicly. So I don't see that as a big thing. What I see as the biggest thing is the fact that they're now at, I believe, 0.9 rev of the PDK for 14A, which tells me that they've got it pretty much locked down with a couple of lead customers, and that's very important.
Yeah. Cool.
Yeah, I would agree. I'm not surprised they made their commitment public. It was a poorly kept secret.
Yeah,
it was going to happen, and I think Jim's right. I think the impending usability of 14A is what's really important.
Yeah. Well, a year a year and a half ago when we were at Intel. What was it? Vision. Yeah, that didn't look like that was going to happen when Lip-Bu Tan took the helm. That was like, what, 2 weeks in? So he was kind of squishy about 14A. So anyway, it's good to at least hear that public acknowledgement. So
yeah, let's face it, you don't spend billions of dollars on fabs and equipment and not use it. So it's going to get used, and it's being used right now for 18A. It's going to be used for 14A.
Awesome. Well, there you have it from Jim McGregor from Clan McGregor and of Tirius Research. How did I do? Pretty good?
Pretty good. You're getting better.
Yeah. Next week, I'm going to try German. How's that? I'm going to work on my own Schwarzenegger accent.
Ich bin fertig, wenn du bist, ja.
Well, I have German in my background too. I've got German, Irish, and Scottish, which basically means I'm good at 2 things: fighting and drinking, and not necessarily in that order.
Yeah, and then, in future episodes, I'm going to force you guys to pronounce my Korean name, which I'm not going to tell you. Massively. So, hey, gentlemen, it's always so great to spend time with both of you. Karl, you as well. Thank you so much for your insights and sharing it with our audience. And so everyone, reach out to Karl. He's at www.cambrian-ai.com. And he's also on Substack and Forbes. Follow his insights. He's been around the block for a long time, and now he's going from HPC to AI to quantum. And along with him is going to be our good buddy, Jim, of Tirius Research. Follow him at www.tiriusresearch.com. And of course, subscribe to our podcast.
We also have Substack, we also have EE Times, and we have Forbes. So look for us pretty much everywhere.
A bunch of stuff. Yeah, EE Times.
In fact, I would just, if I could, put a shameless
do it.
pitch in here.
Yeah.
Just advise everybody, if you can possibly make it to the AI Infrastructure Summit, AI Infra, it will be a huge event this year. Every year it almost doubles. So be there. I'll be there. And
Kevin Hind from Tirius will be there.
Okay. So
cool.
Kevin and I would love to meet you and talk with you at the event.
Yeah, it's kind of like Moore's Law. Okay, so yeah,
And
please
look for me at the FMS Summit next week.
Yes, and where am
The
I?
Future of Memory and Storage Summit.
Ah, yeah, that's right. That's right. Okay, cool. A lot of exciting stuff happening and a lot of exciting coverage that we're going to bring to you in the August edition of our podcast. So remember, follow us on YouTube, subscribe, check out the audio version on Buzzsprout, and you will be able to listen to us on your favorite podcast platform. Also, subscribe to Next Curve Research Portal at www.next-curve.com. And for the tech and industry insights that matter. Gentlemen, thank you so much once again. And thanks everyone for listening. We'll see you next time. Bye.
Cheers.
Bye.